All right, here we go. Lesson 12, transformations to the next level. The first thing I want you to do is do this opening exercise with your group members, and it says find the measure of each lettered angle in the figure below. So go ahead and give it a go and see if you can figure it out. So pause this video. Okay, what you should have got is you should have got A is 115. You should have got B is 115. C is 67. D is 23. E 115. F 124. G 101. H 79. I 79. And J 101. If we think about it, this is 65, so it's easy to get B because that's a linear pair. That's why B is 115. Now, if this is B and this is A, alternate exterior, which makes them the same, and so on, so on. So what you're doing is you're just using your parallel lines. And don't forget that you have triangles here. So if you were trying to find G, we could say this is 56 because of vertical angles. And then here, this is a linear pair, so then you could put your angle in here and then subtract from 180 to get G. So on, so on. All right, let's move on. Okay, now on this one, you were supposed to do a proof. So the first thing you should do is draw your, whoops, let me get my pen, okay. Draw your thing, right? And so always, the first, we're going to put our given. The measure of angle CDE is equal to the measure of angle BAC. That's just given. All right, so CDE, this angle, is equal to BAC. All right, let me erase this real quick so we can see that. Okay, so what we want to prove, let's put that in red, we want to prove that DEC, that this one, is equal to ABC. We want to prove those two. Well, take a look. You've got two triangles, right? So let's go for the first small one first. So if we say that the measure of angle CDE, okay, that's this one, plus the measure of angle DEC, plus the measure of angle DCE, is equal to 180. All right, that's just taking each of the angles, and that's because the sum of the angles in a triangle is equal to 180. All right, we're going to do the same thing for the big one. So the big triangle, we're going to say the measure of angle BCA plus the measure of angle CAB plus the measure of angle ABC is equal to 180. All right, ditto, same reason. Okay, so now that we said that, aren't they both equal to 180? So let's set them equal to each other. So the measure of CDE, oops, that's not CDE, hold on. All right, let's try this again. The measure of CDE plus the measure of DEC plus the measure of DCE is equal to the other one, the measure of angle BCA plus the measure of angle, let's see, BCA, CAB plus the measure of angle ABC. That is just simply substitution. Okay, and then the last thing we're going to do is we're just going to subtract the stuff that they have in common. So if I subtract the stuff they have in common, let's see, so we got We got DEC, so CDE is going to go away. Whoops, wait, I want to keep that one. Hold on, I don't want that one to go away. I want that one to stay. The measure, oops, in blue, the measure of angle CDE, because this is what I'm trying to get, right? So I need to, I need to get rid of that. Okay, CDE is going to go away, and then BAC is equal to CDE, so that's why, because we're doing all this transformation. And what we're going to do is just subtract all those, and we end up with the measure of angle DEC is equal to the measure of angle ABC. And the reason why, that was the subtraction property. All right, now you're going to do a game for a second. And what you're going to do is you're going to sit back to back. You're going to sit back to back with a partner. One partner is going to have one card, and another partner is going to have another card. You're not allowed to look at each other. You can have all of your tools, so make sure you have your tools and you have a piece of paper. So what's going to happen is one of the partners is going to describe what their graph looks like, and then the other partner is going to try to draw what they're describing. So when you're done describing, then you're going to stop, you're going to look at each other and compare your two drawings and see how they look. And then you're going to do that for several different things. And there's a reason why we're doing that, because you're going to find out how important vocabulary is. So go ahead and pause this video. You're going to take, probably about 15 minutes, 20 minutes to go ahead and do this exercise together. And then when you're done, we'll come back and we'll finish up these notes. All right, so hopefully you see how important it is to understand what you're doing and to know some vocabulary. So let's talk about it. It says, explain how to transfer figures without the benefits of coordinate plane can be difficult with some important vocabulary. So we're going to review. The word for, you might want to get your highlighters. The word for transformation has a specific meaning in geometry. Okay, so a transformation f of the plane is a function that assigns to each point P of the plane a unique point f of P in the plane. Transformations that preserve lengths of segments and measures of angles are called basic rigid motions. Basic rigid motions. A basic rigid motion means nothing changes. It's like you're picking up your original one and just moving it around. So you still have the same shape, same angle, same everything. A dilation is an example of a transformation that preserves angle measures, but not the lengths of the sides. So a dilation will change your angles. It'll keep the angles, but it'll change the sides. So it's kind of like when you zoom in on your phone or you zoom out on a picture, that's called a dilation. So in this lesson, we work only with the rigid transformations. So we're not going to do dilation yet. We call a figure that is about to undergo a transformation the pre-image. So the pre-image is what we're going to start with. When we're all done, what we now have is the image. So after we do our rigid motions or our transformations, when we're all done, that's the image. But what we start with is the pre-image, and it makes sense. I mean, pre meaning before, so we start with a pre-image. All right, if you take a look at each of these, this one here, whoops, let me get my pen. Okay. All right, so here we go. This one here is called a rotation. Literally, you're taking this R and you're just rotating it around. Usually rotate it around a point. Okay, now the next one. This is a reflection. And it's kind of like you have a mirror right here. So if you look in the mirror, you see your reflection. And the next one is a translation. And what a translation does is it moves one figure to another spot. It's like it's sliding it over. Okay, so it says use the figures above to identify specific information needed to perform the rigid motion shown. So for rotation, what do we need to know? The first thing we need to know, hold on, I'm gonna change my color. Okay, so we need a somewhere to rotate it about. So we need a center of rotation. What are we going to rotate it about? It's almost like you're putting a needle or something in and then just rotating it. Okay, the other thing we need is some kind of direction. Are we going to the left or to the right? So we need direction, which means like if you're going to the right, that's clockwise. So right is clockwise. If you think about a clock, commonly known as CW, and left is counterclockwise. Counterclockwise, CCW. And you do it by the number of degrees. So like 90 degrees or something like that. Okay. Okay, so if you think about the reflection, right, we had R and R. Ooh, it's hard for me to write that. Okay, anyways, what you needed is you needed a line of reflection. And a line of reflection is a perpendicular bisector of each segment that contains a vertex of the preimage with the vertex of the image. So a perpendicular bisector of the line that connects the vertices of the image and preimage. So, for example, if we look at this R, if I had this vertex and this vertex, this line right here, the perpendicular bisector is the line of reflection, so it should be in the middle. Okay, so for a translation, remember the translation was where it moved it over here. So a translation, for that you need the point to be translated, and the length and degree measure of the angle that the vector makes with the line that passes through P. So we need the length and degree. We need the length and degree measure of the angle that the vector makes with the line that passes through P. That the vector makes with the line that passes through P. And you need the endpoint of the vector. When we do some examples, this is all going to make much more sense to you. All right, so let's talk about this. Now we have now done some work with all three basic rigid rotations, reflections, and translations. At this point, you need to state some assumptions. So any basic motion preserves lines, rays, and segments. So what I need you to do is get out your highlighter. All right, get out your highlighter and highlight rigid motion, preserves lines, rays, and segments. And also a rigid motion preserves lengths of segments and measures of angles. So highlight basic rigid motion and what it is. It's a rotation, a reflection, or a translation. Highlight distance preserving. So a transformation is said to be distance preserving if the distance between the image of 2 points is always equal to the distance of the pre-image. And angle preserving. A transformation is said to be angle preserving if the image of any angle is again an angle, and for any given angle the measure of the image is equal. So your angles are going to stay the same. That's angle preserving. All right, I'm done. Good luck.